Today I'll be discussing about the concept of nested list, where list can contain other lists as elements and exploring various techniques for working with nested list. Nested lists are powerful way to organize and structure data into a hierarchical manner. They allow you to have a list within list, creating a nested structure that can represent complex relationships. This concept is widely used in programming and data manipulation for various purposes. Each element within a nested list can be another list or a non-list item. Each level of nesting represents a new dimension or a layer of information. They are commonly used in programming and data analysis. For example, considering a task management system where each task has a subtask, this could be represented using nested list. Here is an example for nested list. It contains list within a list. Syntax of a nested list. A list is created by enclosing a list within another list. Example for nested list. Here, three sublists are present. Each inner list represents a sublist within the main list. You can access individual elements using indexing like nesting, nesting list by index of 0 and 1 to access the element of 2. Accessing element in nested list requires multiple levels of indexing. The outermost list is accessed using the index followed by the index of nested list and so on. This process continues until the desired element is reached. Modifying nested list involves the same process of accessing element. By targeting the specific index of nested list, elements within it can be modified or replaced. This flexibility allows for dynamic updation of a complex data structures. Modifying nested list in Python involves accessing and updating elements within the nested structure. You can use indexing to access the element at different levels of nesting and then make changes as needed. Here is how you can modify nested list. Example program. In this example, we start a nested list containing sublist of numbers. Here is a breakdown of what's happening in the code. First is we access and modification of element at the first sublist. Second position, index of 0 and index of 1, changing 2 to 99. Second is we add a new sublist of list of 10, 11, 12 to the end of the list using the append method. Append method, it adds the element at the last. And third is we remove the element at the first position of index 0 of the second sublist using the delete statement. And fourth is we modify the third sublist to list 13, 14, 15. After this modification, the nested list will be updated accordingly. Remember that you will be working with the nested list. Changes made to the nested list will affect the original list and vice versa. If you want to create a separate copy to modification, you may need to use copy modulo, copy or deep copy function. Now let's explore the various techniques for working with the nested list. First is iteration. Use Use nested loop for traverse through each elements of the list. This allows you to access individual elements at different levels of nesting. Example for iteration, recursion. Recursion is a powerful technique for working with nested structure and create recursive function that handles each levels of nesting and call themselves for the sublist. Third is list comprehension. List comprehension can be used to create new lists by transforming or filtering elements from existing nested lists. They offer a concise way to process nested data. Fourth is flattening. Sometimes you may want to convert a list into a flat list. This can be done using recursion, where you recursively extract elements from sublist and add them to a new flat list. Example for flattening. Indexing and slicing. Access specific elements within nested list by using index and slicing. Remember that each level of nesting requires its own set of index. Concatenation. Combine nested list by using list concatenation by plus or by extending one list with the element of another list by using extend method. You can append, insert, or delete elements within the nested list just like the regular list. Seventh is manipulation method. Utilizing list methods like append, insert, remove, and pop to modify elements within nested list. You can modify values within nested list by using index. For example, school index of 0 and index of 1 is Alex, who changed to Alice to Alex. Adding elements, removing elements, and modifying elements. Adding elements can be done by simply appending them using the appropriate syntax. Use the remove method or delete statement to remove elements from the nested list. And modification element is done by access the desired elements and assign the new value to modify it. Copying. When copying nested list, be cautious. A simple copy might result in changes affecting the original data. For safety, use deep copy technique. Be careful with copying nested list. Use copy or the copy modulo might lead to swallow copies. Where inner lists are still shared, use the copy.deep copy function for a full copy. Here are some advantages and limitations of using nested list in a Python. Advantages are hierarchy representation, flexible data structure, compact code, and easy traversal. In hierarchy representation, nested lists allow you to represent hierarchical structures and multiple dimensional data, like matrix or a tree, in more intuitive way. Flexible data structures. They provide flexibility in organizing data. You can have lists within lists to create complex data structures that suit your compact code. Nest, nested lists can help simplify your code by reducing the need of separate variables to hold related data. Easy traversal. You can easily traverse and manipulate elements using nested loops, allowing you to perform operations on every element of the nested structure. Limitations are complexity, access time, memory overhead, limited to the homogeneous data. First is complexity. Handling deeply nested lists can lead to complex and hard to maintain code, especially when dealing with the several levels of nesting. Access time. Accessing elements in deeply nested lists can be less efficient compared to the other data structures like dictionaries or arrays. Memorial overhead. Nested list can consume more memory, especially if the nested level is high or the list contains different data types. Limited homogeneous data. While Python list can contain elements of different types, dealing with a nested list becomes trick- trickier if elements have various data types. Remember, the choice to use nested list depends on your specific use case and access time. Accessing elements in deep nested lists can be less efficient compared to the other data structures like dictionary or array. Memorial overhead. Nested list can consume more memory, especially if the nested level is high or the list contains different data types. In conclusion, nested lists in Python are versatile and powerful way to structure and manage complex data. They provide a convenient means for representing hierarchical relationships and multidimensional data. Nested lists are commonly used for tasks such as representing matrix, building data structures like trees and graphs, organizing tabular data, and modeling various real-world scenarios. However, it is important to be mindful of the trade-off that comes with using nested lists. Deeply nested structures can lead to the code complexity, reduce performance, and increase memory usage. Depending on your specific use case, it might be worth considering alternate data structures like dictionaries or sets if they are better suits to your needs. Ultimately, the decision to use nested lists depends on the nature of data you are working with it, with the operations you need to perform, and the balance between the code readability and efficient that you aim to achieve. With careful planning and consideration, nested lists can be valuable too for managing and organizing data in Python. They provide organization, flexibility, and readability to complex data. Understanding the syntax, accessing element, modifying list, and iteration through the list are key skills. Thank you.